In this video, we'll see how to configure DMVPN by using NHRP dynamic configurations. Now we'll see how the configurations can be done, and also we'll verify how the dynamic mapping works if you're using NHRP dynamic mappings. So let's see. So I got the same scenario here. I got a router 1, router 2, 3, 4, where the router 1 will be considered as my hub router and the router 3 will be configured as a spokes. And I'm using the IP address 10.001, 10.002, 10.003 and 10.004. So I'm going to do the same phase 1 configurations, which means on the router 1 we are going to configure a multi-point GRE, whereas on the router 2, router 3, router 4 we are going to configure point-to-point configurations. So because we are doing phase 1 configurations here. Now on the router 1, almost the configurations are more similar to the static configurations what we did in the previous static mappings. We need to create a tunnel interface, assign an IP address, define the source, whereas we are not going to define the destination. Instead we have to use GRE multi-point. Now GRE multi-point allows you to have multiple destinations or multi-point connections on the router 1, and then we just need to enable NHRP on that particular router, IP NHRP network ID 1. But whereas in the previous scenarios we have seen static NHRP mappings where the mapping has to be done manually by the administrator. That is something what we do in case of static NHRP mappings, whereas in case of dynamic NHRP mappings we don't need to configure any extra commands. So the router, the hub is going to build the NHRP mapping information automatically. So this is something a little bit scalable, because we don't need to go to we don't need to really map each and every spoke, a tunnel IP to NBMA address. It can be done automatically. But on the spokes, let's say on the router 3, again this is router 3 configuration here. On the router 3 or router 2, whatever the spoke router, we need to create a tunnel interface, assign an IP address. So I'm using 10.003 here, and we are going to define tunnel source and tunnel destination. Now almost the same commands will be on the router 2 and router 4, similar commands, where the tunnel source is 35.003 and the tunnel destination is 15.001. As we are using phase 1, it will be point-to-point configuration on the spokes. And then the first command we need to configure here is we need to enable the NHRP. That's the one command we need to do first, and the network ID can be same or different, it doesn't matter. And then we need to configure who is my NHRP server. Now in case of NHRP dynamic mappings, probably you need to configure the hub as next hop server, and all the remaining spokes has to be configured as next hop clients. Now in our scenario, router 2, router 3, router 4 will be configured as next hop clients. Now the spokes must be configured with an IP address, or else the spokes will not come to know where to register. Now we need to tell who is the server. Now once you do this, what happens is the spokes has to register with their own NBMA address and tunnel IP address with the server. So which means the clients has to send a registration request. So that's what we call as register messages or register request messages sent by the client to the server, saying that this is my tunnel IP address. My tunnel IP address is 10.002 and my NBMA address is 25.002. So every client has to register with the server, and this is only possible if you define who is your next hop server. If you don't tell, then the spokes will never come to know who is the server or with whom they have to register. So that's the reason if you're using dynamic mappings, we need to enable the NHRP, and then we need to tell the next hop server to send the register messages. Now apart from that, we need to do one more command we need to configure here, IP NHRP map, and the spokes must be configured with the tunnel IP address and the NBMA address of the server. So that is something, one more thing mandatory. Tunnel spokes has to be configured with the tunnel IP address of the hub. This is the tunnel IP address of the hub, 10.001, and the NBMA address of the hub. So that manual mapping is mandatory, we need to configure on the spokes. So apart from that, all the remaining mappings will be learned automatically. Let's go and configure the same thing on our command line here. So I'll go to router. I've got the same topology here. Now I removed the previous configurations. If I go to the command line, just now I added a command to remove that is no interface tunnel 1234. I remove the tunnel configurations and I'm going to reconfigure the tunnels the same on the router 1 multi-point GRE tunnel and on the router 234 point to point by using dynamic mappings. So the first configuration will be on the router 1. We need to say IP address 10.001 and I'm going to use /24 subnet mask, and then we need to say tunnel source. The source will be, and there's no tunnel destination. Instead of tunnel destination we have tunnel mode GRE multi-point, and then finally we need to enable the NHRP, and that's it. So there's a configuration we need to add. We are done with the configuration on the router 1. Let's go to the router 2 and do the similar kind of configurations. Now on the router 2 we need to go to interface tunnel 1234 or any number, and the tunnel IP address is 10.002 with a /24 subnet mask, and then we are going to set tunnel source. Now the tunnel source is again S0 by 0. I'm using S0 by 0 everywhere, and the tunnel destination has to be 115.001. So spokes has to be point to point, and then we need to enable the NHRP, and the next command is we need to tell who is my next hop server, and the next hop server we need to tell that is router 1, the tunnel IP address again, and then the next thing is we need to tell, and the last thing we need to add NHRP mappings. So IP NHRP map, we need to map the hub tunnel IP address has to be mapped with 15001. So if I go with the same thing, let me copy paste everything almost same commands I can copy paste on the router 2. The only thing is I need to change the IP address. Network ID, it can be same, it may not be same, it doesn't matter. Only the thing is IP address will change. So on the router 3 I'm using IP address of 10.003. Let me do the same thing on the router 4. On the router 4 I need to set tunnel 1234, or it can be any other thing like tunnel source, tunnel destination, and the last thing is we need to just define the IP address 10.004 255.255.255.0. Now let's give show IP interface brief. Now I should see the tunnel interface has to be up here. That's 10.004 here, and I should be able to ping from router 4 to router 1. Let me try to ping 10.0.0.1, and let me try to ping to 10.002, 10.003 as well as 10.004. Now all the spokes and the hub, they are able to ping with each other. Let's go to router 1, and if I verify show IP interface brief, now if the interface is up and I should be able to ping from here as well. Let me try from router 1, 122, 123 and 124. Now if I give a command called show IP NHRP detail, it's going to provide me the detailed information, like there is a mapping of 10.002 mapped with 25.002, and you can see 10.003 is mapped with 35.003, and the 10.004 is mapped with 45.004, and the type is dynamic here. Now to further verify this NHRP, what I'm going to do is I'm going to enable the debug NHRP, and then I'm going to make the interface shut down, and then I'll make the interface back to up. So once the interface goes down, probably the tunnel will go down and the tunnel will come up after some time. I can see the tunnel S0 by 0 interface is up. I'm expecting the tunnel has to be up, and you can see the message here. It is attempting to send a packet, sending a registration request via this interface, and then it receives a registration reply from that particular interface. Now whenever you are going to enable, like whenever the clients comes up, probably the first thing what it is going to do is it is going to send a registration request messages informing its own information, what is the tunnel IP address and the NVMe address, and that information will be automatically populated on the router 1. If I give show IP NHRP detail command, I can verify that information. Now this information is updated based on the registration request messages sent by individual spokes.